Hello everyone, let's go over basics of MATLAB. So this is the standard MATLAB window in which you have home, plots, apps, editor, publish. All these things did not exist in the older version of MATLAB. But in the newer versions you will find tabs like this. Then you have an editor in which you can write scripts and functions. You have a command window in which you can write and execute simple commands one by one. Inside a script you can write down all the commands which will then be executed one after the other. You can alternately have functions in which various inputs give rise to various outputs. And through the course of this and next future videos we'll see how functions actually look like. So let's first look at the various variables that we have. A comment is written with a preceding percentage sign, so it's executing nothing. And then we have a scalar. This defines a scalar. If you put a semicolon, it suppresses the output, but you do have in the workspace the variable. You can clear all the variables by writing clear all. You can write a equal to 1 and then you can write clear a to just remove the variable a. So let's write down a equal to 1, b equal to 2. So we now have the two scalars defined over here, and we can just say clear a. It removes a. Screen can be cleared by using CLC. Okay, so let's see various kinds of operations that can be done on a scalar. So if we have a equal to 1, a minus 1, we can assign a minus 1 to b, so b becomes 0 as seen here. We can alternately have the b output. We can write b and then press an enter and it says b equal to 0. Alternately we can create a script. So as a practice I write down clear all the variables before execution of the script and then CLC. It may not be always save the file. In fact, let's rename it as L1. Actually we cannot name a file starting with a number, so let's call it L1. Okay, so it's not always suggested that you clear all the variables before starting, because sometimes in the workspace one may have various kinds of variables stored, and if you give the script to someone else, they may run the script and their variables may get deleted. But I mean, it's a good practice to have this. So let's define a scalar. A equal to 1. Operations on a scalar. B equal to a minus 1. C equal to a square. D equal to a cubed. F equal to a square plus b plus d, and so on. Let's print out all this. So the command is fprintf. So in C, fprintf is usually used to print to a file. Even in MATLAB it's used to print to a file. However, it's also used to print to a terminal. So the standard C reference is to have a file pointer to print to a file. Otherwise simply one uses fprintf. However, in the case of MATLAB we can specify a file ID, but alternately we can simply have single quotes percentage 3.5f \t percentage 3.5f \n, and then let's print out a and f. So this prints to a command window. So this particular window is called as the command window. If you do not specify any file pointer over here, you are printing to a command window. Alternately, we can so instead of printf, one has fprintf in MATLAB. So let's have a file pointer. And we have to declare the file to be opened in a write mode. So I'll let you revise what the various modes of opening a file are: write, read, append plus, and so on. But they are the same. Whatever the C follows, I assume that you already know what the C convention is. If not, you can just look it up on the internet. And then we write fprintf. And then we close the file. So fopen is the function to open the file and give the pointer to FID, and here we need to pass the file pointer as the optional argument, so FID. So once we put FID in front of fprintf, it prints to a file. If we do not specify any file ID, it will print to the command window. So we can run the script, and there we have it. We have all the various things that we need, and we have created an additional dat file which we can open, and we see the two variables outputted. Okay, alternately you can obviously open this in some other software like Notepad and gedit and all these things, but we can open it in MATLAB as well. Okay, doesn't matter. So this is how simple declarations and printing to the terminal and printing to a file takes place. So let's define this as a small block. Okay, so now next thing, let's define the next most primitive variable, which is matrices. Another special case of a matrix, we can have a vector. So let us define V as a vector 1, 2, 3, and because we are done with this particular cell, so we can declare everything above this as a cell. So we have to put 2 percentage signs. So whatever is above the percentage sign is automatically declared as one cell. So the advantage is we can choose to run only a cell. We don't have to run the entire program. The way to run a cell is to simply press Ctrl plus Enter. So if I press simply here, I pressed Ctrl and Enter, it created only the variable V. It did not run the entire program. Alternately, we can right click and we have evaluate current section. So the current section is highlighted as yellow and we can evaluate that. Alternately, we can select a line, make a right click and say evaluate current selection, this F9. So by selecting this and pressing F9, it executes the command. So these are certain things which are useful to have some kind of quick and dirty debugging. I don't necessarily suggest doing this, but it helps. So because we are done with the previous cell, we can redeclare a clear all and CLC. I'm just trying to avoid having to make a new file, nothing else. So after I press Ctrl and Enter, we just have V equal to 1, 2, 3. Now let's see the various operations on a vector. So the first operation is addition. So this was the declaration of a vector. So the addition of vectors is achieved as follows. Let us define two vectors, a equal to 1, 5, 6. We have already defined v above. So let's do the addition. Let's say b equal to a plus b. And say we want to display the variable b. We press Ctrl Enter, and so obviously b is equal to 1 plus 1 2, 2 plus 5 7, 3 plus 6 9. Note here that we have declared the vectors by putting a space between each of the elements, and we have created row vectors. So this is a row vector. Alternately, we can define a column vector as following: 1 semicolon 2 semicolon 3. Okay, if I press Ctrl Enter, if I write here VC, it creates a column vector. And note that we cannot add a row and a column vector. If I write V plus VC, it gives us a matrix. But the reality is it cannot add, it does not perform the standard vector operation. So either we have to convert both to a row vector or both to a column vector. So the simplest way of doing it is V plus VC transpose. So this particular sign, a prime, implies a transpose. So this gives us the addition that we need. So addition of two vectors is done. Similarly, subtraction can also be obtained. Let's try to have a dot product between two vectors. So we have already defined V and A. Let's write down dot product dp is equal to V dot star. So the dot product is obtained by taking a transpose of one of the vectors and multiplying it to the other vector. Okay. So it can be achieved in various ways. It can be achieved by multiplying a row vector to a column vector as follows. So V dot star V star A transpose, and let's the dot product is 29. Okay, let's see if it is really true. So V and A, we have 1 plus 10 plus 18. Yes, we have 29. Alternately, we can do an element-wise operation. What I mean is, element-wise product is equal to V dot star A. So let's first see what entity it creates. It creates an entity which looks like 1, 10, 18. It takes each element of V and multiplies it with the corresponding element of A. So 1 into 1 is 1, 2 into 5 is 10, and 3 into 6 is 18. It takes each element and multiplies each element, and then we need to take a sum of each element. So sum of EP takes all the elements and sums it. And then let us also print the dot product obtained using this method. There you go. So the vectors need not be just entities having 3. In general, we can have an n-dimensional vector. We'll do those later. Anyway, so let us see how to declare a matrix. A equal to, we can declare a 0 matrix by writing zeros 3 comma 3, or alternately we can write, so A we have already used, so we can make this into a new cell and right here something like this. We can write ones 5 comma 5. Okay, so if we do that, we create A which looks like this and B which looks like this. Okay, alternately we can create an identity identity matrix like this. So it creates all the diagonal elements as 1. So these are various ways of initializing a matrix. Alternately, one can force feed the computer. So it's 1 comma 3, 1 comma 5 comma 3 comma 3 semicolon 4 comma 5 comma 0 semicolon 1 comma minus 1 comma 2.1. So let's see how this particular element looks like. It looks like this. Okay, once again we can do various operations on the matrix. Addition is trivial. Okay, so let us add A and C. Let us display that. So here is the first error. The matrix dimensions must agree. Here A was declared as a 3 by 3 matrix, while C was made to be a 5 by 5 matrix. So we cannot add 3 by 3 matrix with a 5 by 5 matrix. So let's simply swap this by B, because B is a 5 by 5 matrix. Okay, so E is obviously 2 2 2 2 and everything else is 1, because B was 1 everywhere and C was 1 on the diagonal. So when you add those, you do get something like this. So addition is trivial. Multiplication with a scalar so we write f equal to 2 into E, for example. There you go. So I just multiplied whatever was here by 2. So multiplication with a scalar is trivial. So multiplication of two matrices. So let's try to multiply whatever we have in F with D. Simply write this. Okay, so there is some error. We cannot do G equal to F into G. So obviously this is wrong. So we have to do F multiplied by D. Okay, so the error is the dimensions must agree. F. So let's see what the dimensions are. We obviously know the dimensions, but just to see when the matrices become very large and so on, if we want to debug such errors, we want to observe the size. We write size of F. It gives us 5 by 5. Similarly, size of D, it gives us only 3 by 3. So obviously we cannot multiply something which is 5 by 5 with something which is 3 by 3. So let us, we can change. So let us remove this, and we declare it as rand 5 comma 5. So it will create a random matrix of size 5 by 5 and between 0 and 1. So let's run this and see what. So let's see first what D is. D is this random matrix and J is this. So it does a matrix multiplication in which the multiplication, we take this row and then we multiply with the row of the we take this row and multiply it with the column and then add. It's the classical. So this is the in index form, this particular operation which is going on is defined as Fij will be equal to, sorry, here Gij, it will be Fik multiplied by Dkj, where the summation over k is implied as per the Einstein convention. Okay, this is what is the matrix multiplication. But sometimes we want to just multiply elements of each element of a matrix to the other. Let us say we have A equal to 1, 2, 3, 0, 5, 6, 0, 1, 0, and let us say D equal to, let's make it as a identity matrix. So let's write down what A and D will be. So if you want to multiply 1 with 1, 2 with 0, 3 with 0, 0 with 0, 5 with 1, 6 with 0, 0 with 0, 1 with 1, 1 with 0 and 0 with 1, we must multiply the elements. It is not a matrix multiplication, because matrix multiplication of A and D would imply 1, 2, 3 multiplied to 1, 0, 0. So basically 1 into 1 plus 2 into 0 plus 3 into 0. This will be the first element. Second element, so first row, second column will be 1 into 0, 2 into 1, 3 into 0. So this multiplied to this. And first row, third element will be 1, 2, 3 multiplied to this. So basically it will be 1 into 0 plus 2 into 0 plus 3 into 1 and so on. But we want a matrix in which the elements of the matrix will be simply the element-wise multiplication. So the first element should be 1 into 1, the first row, second column should be 2 into 0, the first row, third column should be 3 into 0 and so on. So we must do A dot star D. Okay, so there you go. Please verify this is correct. So okay, so here we did the same element wise multiplication, here is the same element wise multiplication. So let us raise something. So we can raise all the elements of a matrix. So we can raise all the elements by a power like this. So look, A was this, and so by performing A dot raised to 2, we have 1, 1, 2 becomes 4, 3 becomes 9 and so on. Okay, so it's an element wise operation. However, A dot raised to 2 is not the same as A square. A square is the square of a matrix, which is different from squaring the elements of the array. So So as a home task, you should try to do these operations on your own. And for our first lecture, I think it's better to stop here so that you can practice. And so in this lecture, we have considered all simple operations on basic variables. And let's see how we proceed from here on.